Okay, so we're going to catch up on a few more advanced topics, dealing with data frames, manipulating them, merging them, stacking them, so forth. We'll start with sorting, which is a fairly simple process in R, but somewhat different than perhaps you're used to if you've used other statistical programming languages. Dealing with duplicates, merging, reshaping, missing values, and so on. So recall data frames are the name R uses for data sets. It's like a matrix, but we can, of course, as we've seen in past lectures, refer to the columns in a different way if needed. We can replace using that square bracket notation, or we can use the $ notation to get at, manipulate, change columns. So for example here, this is an internal state X77 data set. You can run this if you like, or just watch. It's stored as a matrix within R. You can see the list of all the built-in data sets, recall, if you just do data, open, close parentheses. If we read it in, we can look at the first few columns, see some of the names of those columns and rows. We can get at particular columns like population income using this, or using the simple $ reference. We can get at particular rows by looking at the first indice within the square bracket notation. So if we want to import data from the keyboard, I don't recommend doing it this way, but you can use the scan. So notice if you just simply run the command X, gets the object scan, open, close, parentheses, then you can enter the data. X will contain that data. For quick, simple computations, maybe calculating your course average for your students, this might be the way to do it, but I still wouldn't usually do it this way. We have been bringing data in from files. Read.table is the general way to do that. You can also do CSV, and I recommend using read.csv if you do have a CSV title. If you have fixed with formatted data, then you need to specify the widths of those fields. I don't usually use this or emphasize this with students, but that might be useful to you in the future. Read.table. Let's go over the basics of this. We've used this from time to time, but I want to make sure we've gone back over this and understand the code associated with it. The main thing is to realize you put in the file name, whether or not there's a header, meaning column names, and then the separator. So as the default is that there's no separator other than a space. So that's your default. But you could also have tab delimited or comma separated. Of course, you can use read.csv if you have comma separated file as well. You can assign it to skip certain rows. So if you have some leading space prior to the data being entered, you can tell it to skip that. You can use the as-is function, which specifies which columns should just be left as is, as numeric or character, and not converted to factors. A logical should provide instruction to character vectors to be converted to factors. Okay, so a little bit more, let's see. I've already mentioned if you have a CSV file, I recommend read.csv rather than read.table. You can avoid typing the file path or setting the working directory and just use file choose as well. I usually like to set my working directory. That's what I've always done, but this is another option. Here's some examples. So here we're reading a CSV. A header equal true, that's comma separated. We skip the first 7 rows, okay? Here we're reading another CSV. Here though, we're gonna have strings as factors. This will just ensure that the character string values are going to be factors. And I'll go back maybe and show this to you in class if we're face to face, but that's the only difference between this and this command, is that it will be factorized and not left as is. Okay, DR here will be left as is. That was one of the vectors that was character in that example. And then finally here, we reformatted a date informant to look like a date here. So it can be read and used in, say, a time series model. Here you can use file choose. Here's what it would look like. Again, I'm not going to read it here, but you can just run the file choose and then go locate the data. Okay, so the function search is going to show all your search paths within R. That's useful to do, especially if you have a new installation of R, just to be aware of what it is. Attach and detach will attach a data frame to that search path so that it's readily available in R. So for example, the CO2 data set is an internal data set to R. We can compute various things, such as get the mean of the uptake. Okay. Well, if we run the search path command and then attach it, we can see that R will go first to the CO2 directory. We've talked about this previously, but this again is just going to show you that there's a hierarchy in how R goes about finding data frames or variables within its environment, and by attaching it, you put that CO2 at the top of that hierarchy, so it goes first. So if you have another data frame with uptake as a variable, it's not going to go there first, it's going to go to CO2. Then you can just simply compute mean uptake because it is readily available and in that top of the hierarchy. Of course, it is a good idea to detach if you attach, or else you may be referencing variables inappropriately. Okay, I'm going to skip this, but just pause and read through this on your own. It's okay to attach if you're just working on one data set, but I really want to attach multiple data sets at once without detaching. You really run into problems doing this. Plus, if you're doing more advanced things other than just computing summary statistics, I don't see the point, because you have to make reference to the data frame explicitly anyway in most modeling objects. So this is kind of a low-level thing to do, to tell you the truth, and I don't attach it much except for teaching purposes. Here's an example of where you can run into trouble. Since this is using an internal data set, just copy this and figure out what's wrong with using attach here. What has happened? All right, you can use the scan function. Scan's, I think, a little harder to use than read.table, but it's a little bit more flexible. So if read.table is not working for you, or for myself, I might go to scan. Okay, here's an example. I'm not going to spend a lot of time on scan because I'd say 95% of the time I find a different way to read in data. You can export your data using write.table or write.csv. That's the wrapper. I recommend using it this way for saving permanent copies of data frames within R when you know you might want to reference them later. There are other ways of providing access to it for separate R programming sessions, but this is a really good permanent way to do it. And finally, here's an example of exporting your console output. You can do capture output to get, this would be actually your linear model output here. And it'll save it within a text file. This is useful if you want to share it with somebody else. The sync function will divert all of your output to a particular file and name it. You have to name it, of course. That's useful for when you, like I said, are saving or sharing your analysis with other people.